Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So for today's video, we will learn about the chemical properties of benzene. So benzene will undergo electrophilic aromatic substitution, and the reaction of benzene occur at the benzene ring, at the aromatic ring, as the reaction site. So this aromatic ring will experience the electrophilic attack because of it exposed pi electron. So what is the pi electron? So the electrons that are located on the carbon-carbon double bond. So at the carbon-carbon double bond will has high density of electron, so that the aromatic ring will become the nucleophilic site, which is high electron density on each carbon-carbon double bond. So because of the aromatic is nucleophilic site, so it is easy to attack by the electrophile. So that's why the name is electrophilic aromatic substitution reaction. So why substitution? Okay, why benzene undergoes substitution reaction, not addition reaction like alkene? So this is the first reason is that it closed shell of delocalized pi electron give a special stability to the aromatic ring. So this is the electron on the carbon-carbon double bond, so that electron can circulate around the inside the aromatic ring. Because of the delocalization of the electron, it will give the aromatic ring special stability. And then the second reason is the addition reaction yield a product that is not aromatic. So when we compare the addition reaction here, so we see at this carbon we have add H and Cl, so means that the planar structure has been disturbed. Okay, the planar structure has been disturbed means that this compound is no longer aromatic. Compared to the substitution reaction. Okay, compared to the substitution reaction, when we only substitute the hydrogen by other electrophile, so we will see here at this carbon the planar is retained. So this compound is still aromatic compound. So that's why our aromatic ring does not undergo addition reaction, but it undergo substitution reaction. And then in the electrophilic aromatic substitution reaction, we have four reactions, which is nitration, halogenation, Friedel-crafts alkylation, and Friedel-crafts oscillation. So we know that each carbon in aromatic ring in benzene has one hydrogen. So in this reaction, one of the hydrogen of aromatic ring of the benzene is replaced by, in nitration it is replaced by NO2 group. In halogenation it is replaced by halogen, and in Friedel-crafts alkylation it is replaced by alkyl group, and Friedel-crafts oscillation it is replaced by acyl group. So we look at the first reaction, which is nitration. So this one it involves the substitution of one of the hydrogen atom of benzene with nitro group to become nitrobenzene. So this hydrogen is replaced by nitro group to become nitrobenzene. So the reagent used in this conversion is concentrated sulfuric acid and concentrated nitric acid, and condition is 50 to 55 degrees C. So the function of sulfuric acid here is act as catalyst to produce ion NO2 plus. And then for the second reaction, which is halogenation, in this reaction, our hydrogen atom is replaced by halogen to become chlorobenzene or bromobenzene. So the reagent that is used here is chlorine. If you use chlorine, so you will need aluminium chloride or iron chloride as Lewis acid, or you need bromine. If you use bromine, so you will need iron bromide as Lewis acid. So what is the function of Lewis acid here? It is used to increase the polarity of the halogen molecule so that we can produce positive halogen ion, Br plus or Cl plus. That is the function of Lewis acid that is added here. And then in Friedel-crafts alkylation, it involves the substitution one of the hydrogen atom, okay, of benzene with alkyl group. So for example, the alkyl group is CH2CH3. So for example, the alkyl group that we want to substitute the hydrogen is CH2CH3. So this one is the example of alkyl group. So the reagent that we need to use here is the haloalkane that contain the alkyl group, so CH3, CH2Cl, and in the presence of Lewis acid, so if we use chlorine, so the Lewis acid is either aluminium chloride or iron chloride, or if we use bromine, so the Lewis acid is iron bromide. So this reaction will produce alkyl benzene. Okay, so in Friedel-crafts oscillation, it involves the substitution one of the hydrogen atom of benzene with acyl group. So in this example, we are producing acetophenol. So means that our acyl group is C double bond O CH3. Okay, so this is only an example. So what is our reagent is CH3. Okay, so our acyl group should contain the acyl group that we want to add, which is C double bond O CH3. So CH3 C double bond O Cl. Okay, since that we use Cl, so our Lewis acid is aluminium chloride or iron chloride. So there is also the reaction of alkyl benzene. So we know that in the reaction of Friedel-crafts alkylation, we will substitute our hydrogen of benzene with alkyl group, and then this alkyl group will undergo further reaction by substitute one of the hydrogen with halogen. So how this reaction is happen? So we know that to replace the hydrogen with alkyl group, we will use this halogen. Okay, we will use this halogen either CH3 CH2Cl or CH3 CH2 bromine in the reaction that we call as Friedel-crafts alkylation. So you will get this alkyl benzene, for example. So how do we replace the hydrogen in the alkyl group, one of the hydrogen of the alkyl group with halogen? So we will use halogen, okay, X2 in CH2Cl2 in the presence of UV, like in the reaction of alkene. So this one is a halogenation reaction. So that's all for today. I hope that this video will help you to answer all of my questions. So selamat mencuba.